Hello everyone. So today we're gonna solve a hard problem on leetcode. It's called vertical order traversal of a binary tree. So basically the question is we have a binary tree like this and we want to traverse it on a vertical basis or order. So if we start from the left, so here we see 9 first, then 3, 15, then 20, and finally 7. So the output would be, we group it by the columns. So the output is a 2D vector, 9, 3, 5, 20, and 7. So uh, vertical order, then this is the list of top to bottom orderings for each column index starting from leftmost and ending to the rightmost. There may be multiple nodes. This is the important part. There may be multiple nodes in the same row as we see here and the same column. In such a case, sort these nodes by their value. Okay, so we are going to have some sorting to do. So in case we have 3, 15, we sort it by value. If it was 15 in the top, we would do the uh, otherwise. And some other examples here. Example 2. So here, for example, we have 5, 6. Oh, sorry, that was not a good example. We have 3, 15 here based on row. Let's say if this is a row, this is column. We'll have a row first and then columns. So here, if they have the same row and column, we order by value. So how can we define this column map? We'll call it like in the C++ code, we use a map which goes from an integer to another map, which is integer to integer to a vector of integer. Call this column map. Now we need to fill this. So again, I'm going to write it here. Column map is the first key is column, the second is row, the third one is the value of the node. And so we need a for loop basically. So as you can see, the signature of the function is, if I can move this from here, and signature of the function is need to adjust this a little bit more. Okay, it's much better. Is we have a 2D vector of int. There is our function f. Input is, let's call it node, and yeah, let's say it's root. So we will use a helper function to fill this basically, or um, or a pre-order, call it pre-order, uh, do root, and we set 0 and 0 as our um, row and column. So the pre-order, which now we'll call it, again, I will call this F, would be like this. First of all, if n doesn't exist, return, then do an F on left, and so the column -1, row +1, and F and that right, column +1, row -1, and this will generate a hash map similar to what we are going to have shortly. So first we start with F of root, which is value is 1, column 0, row 0. This will give us the left, which is 2 -1, 1, and 3 +1, 1. This will give us F of 4 -2, 2. This will give us F6, 0, 2. This will give us nothing, there's no left subtree. The right subtree would be 7 -1, 3, and this would be F of 5 -1 again, and 3. So the column map is similar to this. We start from the left, all the lefts first, and so column 0, at and row 0 at number 1, column -1, row 1. I'm looking at this guy here now. Number 2, column -2, -2 here, row 2, and this hash map is sorted. That's why I'm sorting it as I go. It's an ordered map. -2, 2, -2, 2. Number 4. Again, we're gonna go here -1, 3, -1, 3 has 7, and -1, 3 will have number 5. So here where the sort needs to happen, and 0, we can again have 0, 2, 6, and 1, 1, 3. So it's similar to if I use another color for the rows. color blue for columns. All right. Now, how can we convert this to this hash map to? Now we need to convert this to our answer, which looks like this guy here. And so this is another challenge. We're going to go. I guess I'm going to write some code for it here to convert and sort as required. So yeah, let's go with void, call it convert. Or actually, never mind. I'm just gonna write the code, pseudocode. So for each pair of this column map, uh, column pair, CP's column pair for in the column map. So we get -2 as the first pair and another map as the second one. And for each row pair of CP, which is 2 and 4 in the first row. And what do we want to do? So 2 will go to, so uh, if these are the indexes, so this is 0, 1, 2, 3. So number 1 is row column number 1. So we push back to the answer. We need to push back a vector, and this vector first we need to build it. So vector temp, vector of int temp, and so we're gonna put everything into a temp that push back rp that's second. And this is, by the way, it's a actually the second uh, is actually a vector, so we just need to sort it. Uh, sort rp that second from beginning, or from the begin to rp that's second, and once we sort it, we can push back to our answer, rp.second. Yeah, I think that's it. Let's quickly debug and see if this converts it. So I write using a green marker now. So first we go through the column map. The CP at the beginning is -2 to 2, 4, and again we go for each row pair, which in this case RP is here, and this is an array obviously. Basically these are in vectors. We sort number 4, a vector which includes number 4, just put it inside of our answer. So answer would have this, and then CP is gonna be the next row, which is this guy, minus 1 2 1 2 3 7 5, and the first row pair is okay. I'll delete this. Erase that. Now the first row pair is 1 1 1 2. This is number 2. We get number 2 sorted and insert. Okay. Okay. Here we need to combine or merge these. All right. So we need that temp, a vector. We need to put, actually we need to define it before here for each column. Int temp, and for each, so temp that insert insert, and yeah, we don't need to sort it here. Delete. Temp insert rp that's sick, and again rp that's sick, or append, and then we sort here and add to answer. Now this is good enough. This is enough explanation. Now we're gonna go write some code for it, and let's see. Okay, now we're gonna go and write actual code for this. As I mentioned, we're gonna need this column map, which is a map of integer to a map of int to vector. And we are missing one of these. Then this pre-order function, which gets a tree node, and if not n, return pre-order and okay, map of int column int row, map of column and row equals to n value to the pre-order left. plus 1. Okay, that's to build. This is to build our map. Now we need this vector answer, and we do this for the same thing, column pair, and and RP here we sort and insert or push back. And we are done here. We can remove this to clean up and return answer. Then we debug, and then we go talk about time and space complexity. Let's run it once and see if we have any compile errors. Yeah. Yeah, obviously this is column map. And this is pushback. Any more compile errors? Okay. Yeah, for some reason my headset is turning off. Let me plug in my because we are doing it twice, which is log n. So the total of this function we will have in log n and space. We'll get to that. Space is big O of n, so this we'll get to the space, but should be big O of n. And then here we have another insertion and another traversal into a hash map, and this was another big O. These two for loops are another big O of n, and we have a sort. So the worst case that we have is n log n. So the total time complexity uh, is O of n log n and the space. We are storing all of these in a map plus these column and row values, so which is neglectable. So for each and sometimes we have like less, like worst case scenario we have like a tree, like a list, so there's no situation like 2020 that we have and like multiple nodes with the same column and rows. uh, that's the worst case. If we don't have this situation, then for each node we have two other values saved, so three more integers. It's like three times the number of nodes, which this is basically O of n. And yeah, so this is the algorithm, but there are more constraints. So node value, number of nodes is in the range 1 to 1000. So I'm gonna submit this to see if we get a like a I'm gonna delete this. This is a column to row to value. I'm going to submit to see if we get a time limit. So basically we don't need to sort it here, but to sort it here basically. And remove this sort. Now we can submit this. All right, so that was it for today. Please let me know if you have any feedback in the comment section, and I hope to see you in the next video. Thank you.